One, we're looking at modeling direct variation. What in the world does that mean? Let's take a look. Direct variation, it looks like this. Y equals some number x. And the non-zero number a, the little number right in here, is called the constant of variation. And y is said to vary directly with x. So as x goes up, so will y. Or as y goes up, x may be going down, but there's a constant variation that occurs. Okay? It's not going to go up and down and like suddenly move up, suddenly move down. It's going to be a constant of variation. Now, so for example, the equation y equals 5x, that's an example of direct variation. The constant of variation is 5. The equation y equals x plus 5 is not an example of direct variation. All right, so if you notice it says something over here to the right of the x, that means it is not direct variation. So let's take a look. This is what a graph would look like for direct variation. When a is positive, or a number bigger than 0, obviously it's going to go uphill. If the a is a negative number, that's the slope is negative, and it's going to be less than 0, it's going to go downhill. So, tell whether the equation represents direct variation. If so, identify the constant of variation. So we are given a standard form. We're going to have to change it into slope-intercept. That way we can actually tell whether or not there is a y-intercept. So let's take a look. So we have negative, we have to subtract our 2x from both sides to bring it over here. So we get negative 3y equals negative 2x. Now, divide both sides by the negative 3. And you'll get a positive 2/3 x. Notice there's nothing over here to the right of the x. Now, that means because the equation can be written in the form of y equals ax, it represents direct variation. The constant of the variation is 2/3, so it's constantly moving at a slope of 2/3. All right, let's take a look at another. Let's do part B. It's in standard form. We've changed it into slope-intercept. Notice it says plus 4 here. So, is this direct variation or not? No. Because the equation is cannot be written in y equals ax, it does not represent direct variation. Let's have you try these 3. Tell whether the equation represents direct variation. If so, identify the constant of that variation. Pause your video and try these 3. Make sure you get them into slope-intercept. Welcome back. Let's see what you did. The first one is not direct variation. The second one is direct variation, and its constant of variation is negative 2. And the last one is direct variation, and the constant is 4/5. Show all your math for these, please. All right, example 2, graph the direct variation. So now we get to graph it. So our slope is 2/3, and notice there's nothing here for the y-intercept. If there's nothing in math, we represent that with 0. So that must mean it crosses the y-axis at 0. So, I mean, technically, we could go ahead and write in plus 0, but we don't traditionally do that. So it's going to cut off the y-axis at 0. So let's take a look. There we go. So letter A is 2/3. We cut it off at 0, and we have a slope of 2/3. Rise 2, run 3. Rise 2, run 3. There it is. There's your second point. That's enough to make a line. All right, let's look at B. On B, we have the constant of variation was negative 3. Cuts off the y-axis at 0, 0. So you drop 3, move over 1. Remember, if it's a whole number, we just place it over a 1. And now you have 2 points, their origin and this, and so you can draw the line. That's direct variation. All right. Let's have you guys try this. Graph the direct variation equation for y equals 2x. Pause your videos. Let's see what you did. You should have put a point at 0, 0. Voila. And then slope of 2/1, so I go up 2/1, plot a point right there, and create a line. Thanks. We'll have one more video tonight. Have a great time.